So this is problem 766. This, I don't know how you pronounce this, matrix. Given an n by n matrix, return true if the matrix is Toeplitz. I think that's how you pronounce it. Otherwise, return false. The matrix is if every diagonal from top left to bottom right has the same elements. So here, 9, 5, 5, 1, 1, 1, 2, 2, 2, 3, 3, 4. So it's true. 2, 1 and 2, they're not the same, so that's how you know this is false. Conditions, M and M both have to be greater than or equal to 1. It doesn't say anything about whether they're going to be odd, even, whatever. So then, basically, there's two types of matrices that comes to mind. The first would be example 1 where you got more columns than rows. But let's say you got the opposite where you got more rows than columns. So 4, 0, 1, and then 5, 4, 0. So all the diagonals are the same. So basically, it's going to be similar. You can either start with the first row, check its diagonals. So go 3, 2, 2, 1, 1, 1, 0, 0, 0, 4, 4, 5. So basically, go with the row and then leftwards and then down. Or you can go up and then to the right. So if you go up, then you're basically checking the first column and then checking the diagonals, and then go right, check the diagonals on the first row. So then it seems pretty straightforward. I could just code this out. So I'll start with the first column. So first we need R and C, which would be the number of rows and columns, length of matrix, length of the first row. So for R in range R minus 1 minus 1. And then we need to, it actually starts at R minus 1. So it starts with R minus 1 and then all the way to 0. And then for each row, we're going to look at we're going to traverse the diagonal. So how are we going to do this? So we could say like I equals to 0. And in this case, that would be the first element. So that would be the element in the first column. So we could say like X equals matrix of row, and column would be I. And then for J in, we could say like J equals 1. While, so then as we're going down the diagonal, for like here, for example, we're going down a row, so R increases by 1. And then the column also increases by 1. So while R plus J is between 0 and R, and 0 less than or equal to C plus J less than or C. So we need R and so R is this. What is C? Oh, okay. So C is 0 because it's the first column. We'll call it C. So R and J. Yeah. So if matrix of R plus J and C plus J is not equal to X, then we know this is going to be false. And otherwise, we increment J by 1. So now the row increases and then the column increases. Okay, so that's going to take care of the first column for the diagonals. Now we need to take care of the first row. So in this case, we already have the first column, so now we start with this one here. So It's going to be for C in range 1 until C, big C. And then we start with the first row. So R equals 0. It's basically just going to be opposite of this. So it goes RC, J equals 1. In this case, here, yeah, same thing. We're going down, so the row increases by 1, and then the column increases by 1. So now you go to X, then J plus equals 1, and then otherwise true. R0, yeah, we start the first row, and then here. Yeah, so it looks like that's it. And it passes all test cases. So yeah, thanks so much for watching.